in persuasion of transferring technical knowledge and just to gear up for the new engineering entrant. Myself, Pranav, is here to deliver today's presentation, Power Transformer Part 61. As the topic is of the continuation, so for your convenience, the link of the previous one is given under the description box. Let's start with condition assessment of transformer oil based on standard diagnosis. Oil conductivity is one of the most significant parameters for maintaining the effectiveness of total insulation systems of a transformer. Basically, insulating oil that would have to entertain a strongly nonlinear conductivity, which mainly depends on the various parameters like electrical field strength, temperature, water content or moisture content, oxidation products, and can also vary with aging. Aging means to their performing years rather. All these elements are forced to enable the oil to conduct ionic current, which is obviously of time dependent because of charge carrier drift processes. As the transformers are configured with multi-dielectric insulation systems, so the electric field distribution would also have been significantly influenced by the permittivity of different insulation materials. Typically consist of combination of mineral oil and solid cellulosic insulation such as pressboard and paper. The electrical conductivity of mineral oils would have to increase with temperature as because of the greater mobility of electron conveying species such as acids or other dissolved substances compared to simple hydrocarbons. The contaminants in oil, if are to be corrosive in nature, then metal corrosion may invariably occur as because corrosion of metals by liquids requires the conduction of electrons. Again, I repeat, the contaminants in oil, if are to be corrosive in nature, then metal corrosion may invariably occurs because corrosion of metals by liquids requires the conduction of electrons. As a matter of fact, oil with higher conductivity would therefore to act as an electrolyte to promote metal corrosion. In case of clean, dry base, new transformer oil, there would have a very low conductivity, which is of the order 10 to the power minus 14 mho per centimeter at 50 degrees centigrade. The accepted value of conductivity of an used transformer oils should be kept in the order of 10 to the power minus 11 mho per centimeter at 50 degrees centigrade. At service condition, the conductivity of an used transformer oil should therefore be assessed with the perception that the resultant value would mainly have to depend on the actual presence of conductive particles as corresponds to a fresh oil sample. That is, to have a comparison study. That is comparative study rather. Comparison between the fresh oil and the used oil. So there may have to quantify free carrier conduction current in the service oil as relative to a fresh oil sample. From the analysis, it has been concluded that an used, wet, dirty transformer oil, if its conductivity is of the order near to the value of 10 to the power minus 8 mho per centimeter at 50 degrees centigrade, then the subject oil may have to act as an electrolyte. Again, I repeat, from the analysis, it has been concluded that an used, wet, dirty transformer oil, if its conductivity is of the order near to the value of 10 to the power minus 8 mho per centimeter at 50 degrees centigrade, then the subject oil may have to act as an electrolyte. The electrical permittivity is one of the fundamental material parameters which affects the propagation of electric fields and that may have to vary with frequency, temperature, and humidity. The electrical permittivity would be a measure of how much the molecules of a material oppose the external electric field. Most important, the relative permittivity of a dielectric is basically characterized by the factor of which the electric field between the molecular charges is to be decreased relative to vacuum of the free space. The relative permittivity indicates the ability of the dielectric to polarize and acquire electrical capacity. The relative permittivity is a non-dimensional physical value. The electrical permittivity of a medium, that is epsilon, here it is transformer oil, would then to be expressed as the product of the permittivity of free space, that is epsilon 0, and the relative permittivity of the oil, that is epsilon r. Therefore, expression can be written in the equation epsilon equals to E0 into that is epsilon 0 into epsilon r, where permittivity of free space epsilon 0 equals to 8.854187818 into 10 to the power minus 12 farads per meter. So, electrical permittivity of the oil epsilon equals to 8.854187818 into 10 to the power minus 12 into epsilon r farads per meter. Relative permittivity of transformer oil, that is epsilon r, is approximately 2.1 to 2.4. The relative permittivity of an insulating material is also to be expressed as its dielectric constant, which has to indicate how easily the material can become polarized while an electric field would have been imposed on that type of insulation. Again, I repeat, the relative permittivity of an insulating material is also to be expressed as its dielectric constant, which has to indicate how easily the material can become polarized while an electric field would have been imposed on that type of insulator. From the expression of electrical permittivity epsilon of the oil, it can be concluded that a higher be the relative permittivity value for an insulating fluid will thus be less exposed to electric field stresses. So, insulating oil of higher permittivity will have a better possibility of conforming to maintain a long-term uniform electric field during its service life. In case of cellulosic paper insulation, the relative permittivity would be around 2.3. For cellulosic paper insulation, relative permittivity would be around 2.3. But whenever the cellulosic paper would have been impregnated with oil, then its relative permittivity approaches near to 7. Transformer at its extreme operational conditions, the solid insulation cellulosic type impregnated with oil can able to withstand abnormal electrical stresses as developed due to high intensity of the electric field. It is therefore the relative permittivity is an important parameter which intends to characterize how a dielectric would have to behave in an electric field. Once the transformer oil gets contaminated by water, gases, oxidation products, etc., then its dielectric parameters would have been slowly decreased. The principal dissolved gases such as hydrogen, oxygen, nitrogen, carbon monoxide, carbon dioxide, methane, ethylene, ethane, and acetylene, which would have been typically emanated as due to prolonged insulation overheating, overloading, oil overheating, partial discharge, corona, or arcing in the transformer, within the transformer. Oxidation process once started in the transformer oil that leads to the formation of the semi-solid hydrocarbons termed as sludge, which settles on the paper insulation. Settled sludge on paper insulation, while starts to propagate as the polarized substances, then condition has forced to instigate an obvious increase of relative permittivity, conductivity, and acidity. The degree of oil degradation and prevention of sludge formation on transformer windings can be technically established by analyzing the transformer oil relative permittivity, specific resistance, and temperature. It is important to note that transformer, if operating under high temperature, may also have to instigate certain breakdown of the organic compounds in the transformer oil, causing the formation of unwarranted carbon compounds, sludge, etc. So, aging of transformer oil would have been accelerated by the ingression of oxygen in addition to thermal stress. Transformer oil, rather a comparative study. International standard IEC 60296 has published the technical specifications of mineral insulating oils for electrotechnical applications. However, This international standard is being revised and updated time to time depending on the state of the industrial requirement and their concerned issues. First edition of IEC 60296 was published in the year 1969. First edition was amended in the year 1972. Again, second edition of IEC 60296 was published in the year 1982, and that has been amended in the year 1986. Third edition IEC 60296 was published in the year 2003. Fourth edition of IEC 60296 was published in the year 2012. And fifth edition of IEC 60296 was published in the year 2020. The fourth edition was published in 2012 concerning with the issue of corrosive sulfur and the detection of dibenzyl disulfide in the unused mineral insulating oil. First to fourth editions of standard IEC 60296 are compiled with the most specific scope, which covered only for the unused mineral insulating oils. And there would have been no clause of provision regarding use of recycled oils. Whereas in the publication of IEC 60296 2020 edition 5 on June 26, 2020, that has to compile with the specifications and test methods for unused and recycled mineral insulating oils. Unused oils that are to be obtained by refining, modifying, and or blending of petroleum products and other hydrocarbons from the crude oil, which has never been used on processed before other than for its production. Again, I repeat, unused oils that are to be obtained by refining, modifying, and or blending of petroleum products and other hydrocarbons from the crude oil, which has never been used or processed before other than for its production. Recycled mineral insulating oil are thus to be produced from mineral insulating oils previously used in electrical equipment that have been subjected to re-refining or reclaiming, that is regeneration, by the stage-by-stage processes employed at the off-site after removal from the equipment. That is taken out from the transformer itself or any equipment, that is circuit breakers or somewhere else, what to use. However, mineral oils treated on-site are actually beyond the scope of the IEC 60296 2020 edition 5. Keep it in mind. Mineral oils treated on-site are actually beyond the scope of IEC 60296 2020 edition 5. From an international consensus of opinion, it can be revealed that the unused mineral oils would have limited resources and that should be managed in a sensitive way. At the same context, the used oil, if it is being persistently deteriorated by the process of degradation or contamination, and once the level of contamination would have been exceeded, then there may have the risk of premature failure of equipment. Addressing all the associated degradation problems of the used oil, the Committee of International Standard had intended to prepare more specific and complete code of on-site practices, and then were to be compiled as of a correndum in December 2013. In IEC 60422-2013, that is 2013, where it is precisely indicated of an on-site supervision, condition monitoring as complied with the prescribed limits of oil parameters and necessary corrective actions followed by relevant test methods for conforming to attain the specific service quality of the used insulating oil in electrical equipment. However, this standard is characteristically applicable only to have the parent quality of the used mineral insulating oils conforming to the standard IEC 60296. Points to be noted that the analysis and condition monitoring of electrical equipment as corresponds to measure concentration level of dissolved gases and furanic compounds in their insulating mineral oils are not in the scope of standard IEC 60422 2013. Again, I repeat, points to be noted that the analysis and condition monitoring of electrical equipment as corresponds to measure concentration level of dissolved gases and furanic compounds in their insulating mineral oil are not in the scope of standard IEC 60422 2013. In IEC 60599 2022, where to indicate how the concentrations of dissolved gases or free gases in the insulating mineral oil can be interpreted to diagnose the ongoing service conditions of oil field electrical equipment, and also there to provide future mode of remedial action. Normally, prime portion of the solid insulation as incorporated in oil field electrical equipment which have been constituted by the cellulosic materials. Cellulose is actually composed of polymerized glucose molecules which under thermal stress would thus to break up into smaller chains forming several compounds such as sugars or and furan derivatives. Major portion of furan derivatives as formed would remain within the cellulosic paper, and the rest portion that has to be in the oil as a soluble state. In IEC 61198 1993, were to indicate how the concentrations of furan derivatives in oil can be interpreted to diagnose the ongoing paper and pressboard insulation assessment of an oil-filled electrical equipment, and there also to provide future mode of remedial action. Paper and pressboard containing a long chain cellulose polymer would therefore be responsible to sustain adequate mechanical strength at their primary stage of operating sequence. As the cellulose has been constantly exposed to heat and oxygen, so over time, the chain of cellulose polymer has that would slowly have become shorter, resulting in reduced mechanical strength. The chemical components of cellulosic insulation used in electrical transformers, while these are become aged in transformer oil, then there would have a relative yield of furanic degradation products. As a matter of fact, furanic compounds are probably the most notable indicators of the cellulose degradation process. ASTM method D5837 and IEC 61198 both are to explain the methods for determination and analyzing the furanic degradation products present in transformer oil. The ultimate result would have been utilized to find out the actual condition as well as to determine the remaining life of the solid insulation system, that is paper and paperboard. Accordingly, that may help to take remedial action thereafter. Let's stop here, further to be continued at later stage. Thank you for listening the video. Kindly do like, share and subscribe. Your subscriptions would encourage to post more videos. Also share your comments or feedbacks inside the indicated comment section. If you have any suggestions or specific topic you want, then let me know in the comment section, please. Thank you. Thank you for patient hearing.